Here's a way we're going to use Cargo Workspace in our production web application, and that will allow us to scale our web application into a multi-service system. And that is because a production application might start as a single service, but will always grow into a multi-service system. Some of these services can be managed by Kubernetes or Lambdas or WASM, but regardless, we always need to normalize behaviors and maximize code reuse. And that is where Cargo Workspace is awesome. So the point is going to go from this place where we have our monolithic code layout, and that is basically the architecture that we have, which is our model store. We have our context and eventually the event, and then the helpers, the RPC, which is independent from the web, the auth, and the utils. And then we have our web with Axum and so on. And that will package into our web server. But as we said before, we're going to have a multi-service system. So what we want is to split our modules into reusable parts. So first, we're going to take all of the model store context and event, and we're going to call that the core. And then all of the RPC, auth, and utils will have their own traits as well. And then our web layer will become our web server service. And eventually, when we have multiple web servers, we might also create a libweb, which will have some reusable web constructs for Axum, request logline, and so on. And from a structure standpoint, we're going to put all of them below the folder crates. And then we're going to organize them in libs. That will be the libs that we're going to use. Services. Right now we have only one, but eventually we'll have multiple. So that way we're going to have, for example, the web server for the end user, IT server for DevOps, and then some AI services, data fetching services, and so on. And then we have our tools, which we might just execute on the development machine or in some build machines that would be useful for some management or some of these kind of things. And right now we have our gen key. Okay, so let's go to our Cargo to ML and see how we're doing it. So first on top, one thing that I like to have is we can use this workspace links now since Rust 174. We're going to put unsafe code forbid. So if you don't have 15 years of experience in C++, do not do unsafe code. And then I like to have the unused allow. And I'm commenting out, but sometimes when I do experimental dev, I turn it on, such as I don't have to have all this warning, and then I turn it off before the commit. And it's awesome that now it's not in the source code, and we can put that in the Cargo to ML. And then we have our workspace. Now, very important, you have to set the resolver to 2 because we're putting everything in our crates. So we don't have any base crate, and therefore we don't have a package. So we cannot specify edition 2021, which would default the resolver to 2. So we have to be explicit into our resolver to 2. Then what we have is our application libraries. So I'm going to put everything under the crates folder. So that is just a personal preference, such as everything inside the same folder and doesn't mix with everything else. And then we have 3 main categories. One is the libs, and that would be all our libraries, our application library. And by convention, I'm prefixing everything with lib dash, such as when I do the use in my application code or my libraries code, I do a use lib underscore. Now it's very clear that anything starting with lib underscore comes from our app libraries and not from external libraries. And then we have our services. And right now we just have our web server, which is for end user. But later, as we discussed, we might have other servers. So that is where they're going to go. And then we have our tools. Right now we just have one, which is our gen key, and that will allow us to grow pretty nicely with the tools. And then eventually, we also have probably a macros folder where we're going to have our proc macros. I didn't put it there because we don't have it yet, but eventually we'll have that. And this code structure should be able to scale pretty well. So now let's look at one of the Cargo to ML for crate. And so the way it structures is like that. We have our package, our name, we are going to put the version 1.0, and we're going to keep it this way to make it simple. We are going to say that we do not want to do the doc test. You can definitely have a different strategy, but in my case, I like to have example code in the documentation, and I don't really need to test it because it's not for external consumption, just for us. But another strategy is completely valid. We have our lint workspace. So that is new in Rust 174. So the current strategy is not to get too granular in the lint and to have everything manage at the root. And then eventually we might change this strategy. And then if we look at the dependencies, we have the sections. And we can see that we have our app libs. And we're going to have our app libs relative. And we are going back up to the crates folder and then back down. And the reason of that is because regardless where I am in the tree, if it's within a service or within the crate, I can copy that and put that into another crate and everything will work fine. If I want it to be too smart, I just need to go one level up to go down to my utils. Then the problem is I couldn't take this line and copy it in my services. So that is a little technique I'm using so that I can reuse those lines everywhere. And then I have all my sections with my dependencies. The trick here is to make sure that we are as minimalistic as we can into what we need to import for each lib. So we don't want to have crates that are not needed. So sometimes I copy everything and then I remove until it breaks, such as I can just have what is needed and then nothing more per crate. Now it's important to note that we only have one cargo lock. So there's one cargo lock for everybody, but then each crate has their own cargo and define what they need to be able to run. Now there's an important aspect of crates in Workspace is you cannot have mutual dependencies. So for example, we cannot have the core that depends on RPC, and at the same time, RPC that would depend on core. That wouldn't work. So you have to make sure that when you split your application code in subcrates, you have only one dependency flow in a way. So in our case, we have the web from the application that depends on RPC. The RPC will depend on utils, but utils will not depend on RPC, for example. And core will use the auth, as well as a web can use auth, but auth cannot depend on core. So that is a way that we need to structure our code. And this actually makes a lot of sense. And then once you get the hang of it, things are very clean. And there's one other thing here that need to be taken care of. And that is now that there are different crates. When we have a component over in the libcore, for example, CTX, and in our web service crate needs to implement from request parts from Axum on the CTX struct from libcore. We cannot because both the trait and struct are external to the web server crate. And this is when we need to implement the new type pattern with a wrapper. So let's look at the code here. It's going to become clearer. So in the code, if we go to our libcore, and we're going to see that we have our CTX over there, and that is part of this crate. But in the web server, we also, in our MW authentication, if we go to our CTX extractor, we realize that we need to implement from request for CTX. But we cannot because both CTX and from request parts are external to the web server crate. Another alternative will be to implement from request parts inside the libcore, but that would defeat the purpose because now the libcore will depend on Axon and on the web layer, which it shouldn't do. That was a whole point of the decoupling. So the way to work for that is to use the new type pattern for our CTX. And my best practice is when I have end with letter W, uppercase, this is a new type wrapper of a tuple of 1. So now what I've done here is updated the code where I implement from request parts, which is from outside of the web crate, obviously because that is from Axum. And I cannot do for CTX, but I can do from CTXW, which now belong to this crate, just there. And I just put the CTX inside. And then in our code, for example, on this one, having the result of CTXW is okay, so we can just return the error. And then when we need the real CTX, so for example, in our router RPC, we need to have the real CTX. So the extractor is for CTXW now, but we just do let CTX, CTX0, and that will give us our CTX back, which then we can pass to the rest of the function. So that is a new type pattern when you need to implement an external trait on the next RAL type. So one of the things that is important is if you go to your cargo and you config, or anywhere you set your environment variable. So we're using the .cargo config technique. But make sure that in your Rust log now, you need to make sure to change the environment variable for tracing, for example, because now the crates have different names. So you need to make sure to have those. And then everything should work pretty nicely. And the way that we're going to run that is going to be, for example, with cargo run-p and then the crate name. So for example, we do a gen key and that will run our gen key. And then we can do a cargo run-p web server. And now we can run our quick dev in another terminal. We do cargo run-p web server, and our quick dev is an example of the web server crate over there. So we do -- example quick dev, and that will run our quick dev, and we get our API call response, here list tasks. So one last tip is when we are migrating from our monolithic code to a workspace code layout, I typically do from the bottom up, meaning I start with parts that have the less applib dependencies. So I started with utils, which has none, then librpc, then I did the auth, then I did the core, and at last I did the web server. And every time I'm moving, I'm creating the subcrate and I make sure that everything compiles before moving to the next one. It's a little bit tedious, but once you have done it, then it goes very fast. And now I already made a commit, which is committed in GitHub as our third episode of our Rust 10x web app series. So you can check the code over there. Everything is working nicely. Hope you like the new voice, still Jeremy coding every line, scripting every word, and editing every frame. I'm just lending my voice. Until next one, happy coding.